Part 7, Differential Operator. Lecture 15, Spherical Coordinates, Christoffel symbols of second kind. So this is a particular case of the generalized coordinates. Still extrinsic geometry, three-dimensional space. This is the formula for the Christoffel symbol of second kind. This formula, it was derived previously, and we use the characteristics of the spherical coordinates, in which the metric tensor is diagonal, okay? And the inverse is equal to 1 of r squared, 1 of r squared sine square of phi. So this, it was done, what was discussed before. Now, we will apply this metric, the components. This is a covariant, this is a contravariant metric. Okay? This will apply to obtain the Christoffel symbol for the spherical coordinate. You see, it's quite simple, okay? Put a piece of paper on your side and try to do yourself. You see that many components of this Christoffel symbol will be zero. So this here, this derivation, we are only worried about to compute the non-zero components of this Christoffel symbol of second kind. Now, we start, remember, this over here is GRR, R2 is G phi, and this one is G theta, okay? Because the diagonal only is different from zero. Likewise, the same. This is 1 of GRR, 1 of G, in this case, phi, and this is 1 of G theta. Okay, that's the inverse of here. No, we already discussed this. Now let's apply to the non-zero Christoffel symbol. First, you just, attention now, you see here, you come here, you see this is R2, G phi is, this phi is R2. You just substitute, so you get to R over here, okay? And this component, G theta, is just R2 sine square of phi. So just take the derivative. It's quite easy, see? Likewise, G theta, the partial derivative with respect to phi. You come here, and derive this one. This is the components of G theta. You see? You just take the derivative. That's all. You see? Step 2. Now I will calculate for each non-zero Christoffel symbol. The first one is R, the upper index. This is JK. JK will be phi in this case, okay? And will be theta. Okay? You just take the derivative over here, and then you substitute just in this formula, and the non-zero Christoffel symbol lead to this here and this over here. Just easy to see, just derivatives. Now for the other formula, you see the formula, now you apply this gamma JK phi. Attention now, JK can be phi, or in this case, I'm sorry, RR or theta, because I already have phi over there. You see, in this case, you have over here, you just take the derivative of this and you obtain 1/r. See? And this one, see, you have theta here. Just look at here, come here, always. This is GRR, G55, and G phi, G phi and G theta. You just come from here, look at here, and take the derivative. So, likewise this one. Now, this is for R. Now this is for theta over here. See? Again, you just substitute and see G theta tensional. G is 1/r squared. Okay, because this is contravariant. You just look at, come here and see it. How you gonna choose? This is G theta. You just substitute and take the derivative. Likewise, this one, that's clear. Now, this is a summary, okay? A list of non-zero Christoffel symbols. I just copy from step 2, see? I put here all together. Attention, these Christoffel symbols will be also analyzed in the intrinsic geometry, exterior algebra. Here is extrinsic geometry, 3D. This is called exterior algebra. Okay, that's it. That's quite simple. Just take derivative. See?